To join two tables together is to combine their information into one table. This is useful because often the information that you want to analyze appears in multiple different tables. And yet, all of the operations we've looked at so far work with one table at a time. So, how we put all that together is that we take the multiple different tables, join them together until we have one table, and then we process it with group and sort and where, etc. So for example, if you're curious whether rain affects traffic, and you have a table of when it rained and a table of the amount of traffic, you need to join those tables together in order to get one table that says for each day how much rain there was and how much traffic there was. Then you can perform your analysis, perhaps draw a scatter diagram. There are many different ways of joining two tables together. We'll focus on the most common one in this course, which is conventionally called the inner join, but we'll just call it a join. It's the most typical kind. So here's how it works. Let's say you already have two tables. Here we have a table of different drinks. These are drinks you could order at cafes in Berkeley, California. You can order a milk tea at a cafe called T1 for $4. And then let's say we have some coupons. The coupons aren't for particular drinks, they're for any drink in the store. So at T1, I have a coupon for 25% off any drink that I want. Nefelli's a different cafe, I have a coupon for that. And I actually have a second coupon for T1 that gives me 5% off any drink. So the question is, what will be the final price for a drink if I apply one of my discounts to one of the drinks that's available? We join the drinks table to the discounts table, saying which columns we want to join on. Those are the values that we'll try to match in order to build discounted drink rows. So here's the syntax. We say what table we want to join first, dot join. Then we say what column in the drinks table we're going to use to match up with rows in a column of the discounts table. So here's the second table that we're going to combine. And then this is a label for a column in the discounts table. What we get out is a joined table. Each row in the joined table is a combination of two rows, one from drinks and one from discounts. So here we have the Nefelli Espresso for $2 row combined with the Nefelli coupon for 50% off row. And we've put them all in one long row. Now notice the column orders have changed. I'll talk about that in a moment. But all the information is there. The cafe's Nefelli, the drink is espresso, the price is $2, and I have a coupon for 50% off. Notice I haven't applied the T1 coupon of 25% off to Nefelli because that's the wrong cafe. I've gone through the trouble of matching up locations in the discounts table with cafes in the drinks table so that the resulting rows only have the same value in both, meaning that I'm only using Nefelli coupons for Nefelli drinks. So the syntax of the method call that actually performs the join is that you first write down one of the tables, drinks, so match rows in this table using values in this column of that table. So we're now looking at the cafe column of drinks and we're matching it up with rows in the discounts table that have the same value in the discounts location column. So there is a reason why there's no location column in the end here. It's because location and cafe have the same values, and we've gone through the trouble of matching them up, and so we only need one column to represent the matched value that appeared in both cafe and location. So when you look at the column labels, you get column labels from both tables. They show up in the order that we chose here. So drinks come first, discounts come second. When we joined on a particular column, the cafe and the location, we don't need to duplicate that, so we just use the label from the drinks table because it came first. And then we have all the other columns from drinks, which is drink and price, and all of the other columns from discounts, which happens to just be a coupon. And that's all of the columns in both of the tables, -1 for the overlap. Just to trace what happened, this row combined with this row to build this row, and we got all of the information in both of these rows together in one row. That's useful because then we can perform column arithmetic. So for example, we could get the price column of the result, the coupon column of the result, multiply them together, and then we know what kind of discount we're looking at. One consequence of joining is that you end up with the joined column in sorted order. And it only contains values that appear both in the cafe and the location column because that's what we matched up on. So for example, you can't buy a discounted Abe's Espresso because Abe's doesn't have any coupons. And this one's sorted automatically because that's actually part of the process of creating the join. When you figure out which rows combine with which other rows across the two tables, the way that's done is that they both get sorted, and then you kind of read down the list and look for matching values. Since we've matched in this way, we can expect that the values over here correspond to each other. So I can get a 50% discount off of this $2 espresso. And one last little detail. You'll notice that milk tea showed up twice. That's because there's two different coupons for it. And Nepheli's 50% coupon showed up twice. That's because there are two different drinks offered at Nefeli. So what you're seeing here is all possible combinations of a matching row from here and a matching row from here. If you were to join in a separate order, for instance, discounts.join drinks instead of drinks.join discounts, you'd get the same rows. It would just affect the label here. It would be location instead of cafe because discounts came first. And the order of the columns would be different. You'd get the discount columns first, which is coupon, and then you'd get the drinks columns. But you'd have the same information, so it doesn't matter which order you join on, but you do have to be aware of how the output will come so that you can work with it after you've created the join table. Well, that was a lot of explanation. Let's try it out together. I'll import data science, and then I'll construct this drinks table just like it was on the slide, and the discounts table just like it was on the slide. And I've just constructed them from scratch using the with rows method here in order to write down all the rows. And I use the with columns method here in order to write down this one by columns. You could do it either way. I just wanted to show you that these are two different options for creating a table from scratch. And now we're ready to join. T equals drinks dot join the cafe column with the discounts table using its location column. And now what's T? T is the join table, which has the 4 rows I showed you on the slide. Now this doesn't change either the drinks or the discounts table. Those are both the same. It's just constructed a new joined table which had rows from both. Now if I want to know what's the discounted price, then I'd have to add a new column, 2T, discounted. And what discounted does is it takes the original price and subtracts off the coupon amount. One way to write that is T.column price times 1 minus T.column. I don't want to write coupon percent off, so I'll just call it column 3 divided by 100. So I can get an espresso for $1, a latte for $1.50, or a pearl milk tea for $3 or for $3.80, depending on which coupon I use. Let's say I don't want to just buy one drink, I want to buy 2 drinks. I'm going to build a joined table where I take the drinks table and I join it using the cafe column with the drinks table. I'm not going to put anything here. Implicitly, it uses the same label for the second table as it did for the first if you don't specify. And 2 is now a table of all the ways that I could go to one cafe and buy 2 drinks. The only thing I could do at Abe's is buy 2 espressos, because Abe's only sells espresso. That's not true. It's a great cafe, sells all kinds of things, but according to my table, only sells espresso. Nefeli sells espresso and lattes, So I could buy an espresso and an espresso and a latte and an espresso, or a latte and a latte. So you can see that because there are two options here, we end up with 2 times 2, or 4 different options for buying 2 drinks. And we have drink and drink 2 and price 2 as the columns, because those were the columns of the drink table and the drink table. And finally, if I go to T1, I'll buy 2 milk teas. And if I wanted, I could extend this table, for example, with the total price just by adding up this column and that column. Okay, now you know how to join.